So in this video, we're going to talk about permutation. So what is a permutation? A permutation is an arrangement of things in a definite order or the ordered arrangement of distinguishable objects without allowing repetitions among the objects. In general, if n is positive integer, then n factorial denoted by this. N factorial is the product of all integers less than or equal to n. So n factorial is equal to n times n minus 1 times n minus 2 times and so on times 2 times 1. And remember, as a special case, we define 0 factorial is equal to 1. Always remember that. P sub n sub r. In short, the number of permutations that can be made with n things taken r at a time. So permutation of n things taken r at a time. We can now obtain the formula for computing the number of permutations of n things taken n at a time or taken r at a time. So this is the permutation of n things taken n at a time, and this is the permutation of n things taken r at a time. So formula, what are those formula? First, so the number of permutations of n things taken r at a time is given by n times n minus 1 times n minus 2 and so on times n minus r plus 1, or the permutation of n things taken r at a time is equal to n factorial over the n minus r factorial. So that's the first formula. The permutations of n things taken r at a time. Then, the second formula is the permutation of n things taken n at a time is given by n times n minus 1 times n minus 2 and so on times 3 times 2 times 2 times 1, which is equal to n factorial. So those are the formula of permutation. First is the permutation of n things taken r at a time, and the second formula is the permutation of n things taken n at a time. So let's have an example. Evaluate each permutation. So if we have P, 7, and 2, permutations of 7 and 2. So solution, we use the formula of permutation of n things taken r at a time, which is n factorial over n minus r factorial. So that's the formula that we are going to use to solve the permutation. So let's say the permutation of 7 taken 2 at a time is equal to the 7 factorial over the 7 minus 2 factorial is equal to, so 7 times 6 times 5 factorial over 5 factorial. Then, cancel the 5 factorial. So, 7 times 6 is 42. So, therefore, the permutation of 7 things taken 2 at a time is equal to 42. Okay, 5 factorial means 5 times 4 times 3 times 2 times 1. So that is 5 factorial. Next, let's try another example. How about permutation of 9 and 6? So again, using the formula, so permutation of 9 and 6 is equal to n factorial over n minus r factorial. Okay, so our n is 9 factorial all over 9 minus 6 factorial. So 9 factorial, we have 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial all over 9 minus 6 is 3 factorial. Okay, so we can cancel the 3 factorial and get the product of the remaining numbers. So 9 times 8 times 7 times 6 times 5 times 4, which is equal to 60,480. So that's the permutation of 9 and 6. Again, 3 factorial is, so 3 factorial is equal to 3 times 2 times 1. So this is now the permutation of 9 and 6, or permutation of 9 things taken 6 at a time. Last example. Okay, another example. So permutation of 5 and 5. Again, using the formula. So n permutation all over n minus r permutation. So our n is 5. So 5 factorial over 5 minus 5 factorial. So 5 factorial over 5 minus 5 is 0 factorial. And remember that 0 factorial is equal to 1. So we have 5 factorial over 1. So what is 5 factorial? Then we have 5 times 4 times 3 times 2 times 1 over 1, which is equal to 120. Okay, so remember again that 0 factorial is equal to 1. Okay, so that's how to solve permutations. How about permutation with repetition? Permutation with, okay, so we're going to talk now about permutation with repetition. So the number of permutation of n things where a things are alike, b things are alike, c things are alike, and so forth is the permutation of n factorial all over the a factorial, b factorial, c factorial, and so on. Okay, so let's try an example. Find the number of distinguishable permutations for the letters in each word. Example, our first word is, we have substitution. Sorry. So in the word substitution, okay, solution, how are we going to solve the permutations of the letters in the word substitution? Okay, there is a total of 12 factorial permutation in the word substitution because there are 12 letters: S, U, B, S, T, I, T, U, T, I, O, N. So 12 letters in the word substitution. But there are two S, two U's, two I's, and three T's. Okay, those are the letters in the word substitution, which is, okay, so the two S, the two U's, and the three T's, and two I's can be permuted in 2 factorial, 2 factorial, 3 factorial, and 2 factorial ways respectively in each permutation without altering the result. Hence, the number of distinguishable permutation is given by permutation of 12 factorial over the 2 factorial, 2 factorial, 3 factorial, and another 2 factorial. So 12 factorial, we have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial all over. So the first 2 factorial is 2 times 1 times another 2 factorial. We have 2 times 1, then another 2 factorial times 2 times 1, and times the 3 factorial. Okay, so cancel the 3 factorial. Next, simplify. So we have 3 2's, 1, 2, 3. When you get the product of that, we have 8. So you cancel the 8 here in our numerator. And it becomes 1. Then, simplify and get the product of the remaining numbers. We have 12 times 11 times 10 times 9 times 7 times 6 times 5 times 4. So get the product of that. We have 9,979,200. Next, so that's the permutation in the word substitution. Next, another example. How about we have the word perpendicular? So in the word perpendicular, we are going to get those letters which is alike. So we have 2 P's. What else? 2 E's. And we have 2 R's. Okay. Then, count how many letters are there in the word perpendicular. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So we have permutation of 13 factorial over the 2 factorial, another 2 factorial, then another 2 factorial. So try to solve. So what's the factorial of 13? 13 times 12 times 11, 10, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial. Again. All over the 2 factorial times the factorial of these two. We have 2 times 1, and the factorial of another 2 times 2 times 1. So cancel this 2 factorial. Then 2 times 2 is 4. 5 times 4 times 3. So cancel this 4. So we have the remaining number are 8, 13, 12, 11, 10, 9, 8, 7, 6 times 5 times 3. And get the total or the product of that numbers. We have 778,377,600. So that's the total number of permutations in the word perpendicular. So that's how to solve the permutations and permutation with repetition. I hope that you've learned a lot, and do not forget to like, share, comment, and subscribe my YouTube channel, JNix_mathematics tutor, for more videos to learn about mathematics.